Okay, go ahead and get started. Well, thank you all for coming to Ballroom A for my session, which is titled Tips and Tricks of Effective iOS Developers. First off, how many of you are already iOS developers? Okay, and how many of you are just interested in it? Okay, almost the same hands. Okay, good thing you're doing what you're interested in, I guess. Okay, so my name is Ben Scheirman. I come from Houston, Texas, and I write iOS and Rails code mostly. You can find me on the internet at Subdigital on Twitter and GitHub. And I work for a company called Chai1 in Houston. Work with some amazing people. We do iOS, Rails, and Android for small companies and enterprises. And in addition, on nights and weekends in my copious free time, I record screencasts. So I have a site called nsscreencast.com, and I produce a screencast every week on there. And they're short and focused, between 10 and 20 minutes. And you can go find some free videos on there. And if you like what you see, it's $9 a month, and you get access to the whole back catalog. I have about 115 videos up, and a new one comes up each week. So check that out. So the title of the talk is Effective Developers. And I think it's good to start off with a definition of what effective developers are, or what does effective even mean. So the definition of effective is successful in producing a desired or intended result. And that's a little bit too broad for our scope. I want to talk about effective developers. What does it mean to be an effective developer? So my definition is just a list of sort of traits that effective developers possess. So one of them is effective developers fix problems. Effective developers write code faster. They confidently refactor their code. They write better code. They write fewer bugs. And effective developers just get things done. I'm sure we all know people that we look up to as developers, and you go and you're like, well, how is that person so good at what they do? They seem to be producing so much, and they write good quality code, and they don't write as many bugs as I do, or whatever. Ultimately, effective developers ship better software. And that's kind of one of the things I want to zero in on is what can we do to ship better software. So why am I up here talking about all this? It's not that I feel like I am the most effective developer. In fact, it's quite the opposite. Oftentimes I feel like this guy. However, I aspire to be effective. It's just one of my professional goals that's ongoing. I always want to get better at what I do. And so even though I feel like I'm an accomplished iOS developer, I learn all kinds of new things from people in the iOS community, and I'm always trying to challenge myself to be better. So I'm going to go through some tips of Objective-C and Xcode and general software design and practices that we can go through, starting off with the Objective-C tips. So the first one is pretty straightforward. This is a rule of mine, always use braces for conditionals. So Objective-C being a C-based language, you can write code like this. If self is hungry, then self eat burger. And I've indented it, and with spaces, not tabs, by the way. And this will work, right? If you are using a C-based language, you can omit the curly braces, and this will be fine. And the equivalent code on the right with curly braces. So what happens if I decide I'm just going to add some more logic in that if block? So after I eat a burger, I need to take a nap. And I've indented it 2 spaces here, but I've forgotten that I missed the curly braces there. So the one on the right is bug-free. The one on the left leads to things like this, the go-to-fail bug, which if you are running a Mac computer, a couple months ago, I guess it was, this bug had shipped in Mavericks, and notice we have 2 go-to-fails, both indented but without curly braces, which means that no matter what happens in this code, this check never happens, which is bad. So I think it's a small price to pay, 2 extra characters for avoiding things like that. I like to use class continuations for private properties. I don't like exposing my internal state to the world. So the header file is literally your contract to the world. And if I choose to name my variables after, I don't know, superhero characters or something, that shouldn't matter to the outside world, right? So I have a well-defined interface for my objects. And the private state goes in a class continuation. So in Objective-C, you can declare your properties and instance variables and things like that in the public header file, which is just kind of bananas if you're familiar with other platforms. That's a little weird. So I don't ever want anybody modifying health or the texture directly, right? I've got an interface for that. I've got an interface for hitting the player, which should subtract some defined amount from the health. If I exposed the health property publicly, then some other person could say, oh, I'm just going to subtract 25 from health every time I hit them. You can also do this for IB outlets. So if you do this in Interface Builder, Xcode, you'll get the little empty circle and you can drag a connection from here to the UI element that this refers to, or vice versa from Interface Builder to this section of code. So again, unless I have a reason to expose my UI properties publicly on the class, I will use the class continuation syntax to keep it in the implementation file. This one's about naming, particularly important in any software platform, programming language, or environment. And I think it's especially important here because we've embraced Objective-C's sort of wordy, descriptive nature. And sometimes I see methods like this. So it returns an NS date, takes an NS date. It's called next date. What would you guess this does? If you ran across this method, what would you guess it does? Does it return tomorrow? I don't know. This one is much more descriptive. Next billing date after date, which that makes a lot more sense. I can already sort of build what I think that this method does. And I haven't written any documentation for it yet. Documentation might be important for this method, but I've gone a long way by just adding a descriptive name for this method. You should always name your single parameter bool arguments. So what I mean by that is sometimes you see code that looks like this. Self show panel no. What does that mean? Does that mean I'm hiding the panel? No, it means I'm not animating the show panel. So what you should do for this is have show panel animated, right? And you've seen this in Cocoa Touch framework. You see this all over the place where they'll say show panel animated or dismiss modal view controller animated. That's much more descriptive. Another thing that I don't see people doing a lot is adding documentation comments here, right? Xcode now is smart enough to pull these in and give you a little summary description of your comments. All you have to do is hold down Option and click on a symbol, even your own code, and it will do this. Now notice the thing that I put in here, the comments that I put in here sort of get filled into these little buckets, and it's got params right here, param date. That's a special syntax so that it knows that that's a parameter right here. And then the return type, if the return type has a special case, like maybe if you're on a leap year, the return value is undefined, so you would have to document that here. But this isn't just regurgitating the method. If it just said this returns the next billing date after a specified date, then it would be useless, right? The method already says that, and I don't think you need documentation to be redundant. Especially since code changes, you're not forced to ever go back and change your comments, so comments often lie to you. So I think you should reserve these types of comments for things that are exceptional, notable, right? So this is telling me about banking holidays and things like that, which is important information that I might need to know about. So here's a tip I use all the time to lazy initialize properties. So say I have in my viewDid load, I've got a fetch results controller. I'm calling perform fetch. And of course, I'm not doing any error checking because no effective developer does that. So where is this thing created? Well, it's created in its getter method for a property, right? So I've overridden the getter method for this property. And I'm just checking to see if my fetch results controller is nil. And if it is, then I create it, right? So the idea here is that I don't need to bother my viewDid load code with the initialization of the stuff. I just use it. I pretend that it exists, and then it gets created on demand. So, and the second time I call this method, it's a no-op, right? Because we already assigned the instance variable that we're going to be returning. So notice I need a fetch request for this. So again, I've deferred that to a property, pretending that it exists. And that ends up looking like this. So if I don't have a fetch request, then I create one and I return it. The benefit of doing something like this is, let's say we needed to ditch these objects, right? I don't need to worry about where they're initialized. I just set them both to nil, right? The next time they're used, they'll get created again. So I think this is a nice pattern. Sometimes, or if you remember back in the old days when you had to do manual memory management, you had to implement view-did unload so that you could undo things you did in view-did load. You needed to make sure that those things were balanced so that when you went into view-did load again, you're not trying to reinitialize something that was already initialized. So I use Refactor Method judiciously. It's one of my first sort of code cleanup tactics. I see long methods, I want to try and extract concepts. Unfortunately, Xcode's tools for this are still terrible, but you don't necessarily need a refactoring tool to do a quick extract method. So say I have a table view self-arrowed index path implementation here, and you've all seen code like this. The first thing I do is dequeue given that particular reuse identifier, which in later versions of Xcode will create one if it needs to, right? Because we've registered ourselves beforehand. The next thing we need to do is get people in this particular section. So in this example, we're building like the address book, right? We've got a bunch of names in A and a bunch of names in B. So I get the people in that section. So I have to reach into the sections array for that particular section. So I've got a bunch of sections, and my data is already sort of formatted in this way, so it's easy to retrieve. Then I get from the people in section array, I pull out that indexPath.row. Then I set the text label.text to that person's first name and last name concatenated together. Set their detail label text to their email address, and then I return the cell. So how many of you have seen code like this? How many of you have written code like this? Right, all of us probably. It's pretty straightforward, except there's so many concepts going on here at once. It's just at a glance, especially if you're not familiar with Objective-C, it would be really difficult to just immediately know what's going on here. So I'm going to use refactor method or extract method and clean this up a bit. So the first thing I'm going to do is give myself a facility for returning a person at an index path, right? That's a separate concern. Like the data structures I have laid out, it doesn't matter. At this level, I'm only concerned with getting the particular person for this index path. The next step is to concatenate that person's first name and last name. And you know what? I can just put that on the model. Make a read-only property called full name, which does that thing, right? So I've cleaned that up considerably. And even still, sometimes it's handy to just have a method update cell for person that takes your model object and does the right thing, right? So these methods may have just gone right below here, right? But they're shorter, they're more focused, they're easier to read. The next tip I have is an important one, and that's to understand dependencies. So when you write a method, and that method calls into another method, you have a dependency between these two methods, right? So we draw a directed arrow towards the thing that you depend on. That also works for classes, so I've got a class on the left that depends on the class on the right, because it directly calls things on that class, and probably instantiates that class directly. Right? This works with class clusters as well as in entire applications. So understanding this is really important because you want to avoid situations like this, right? This is an automated tool that generated a class diagram, a dependency diagram for, I don't even know what this application does, but it looks pretty terrible, right? We can tell the state of the code is not good by looking at this graph. In addition, I'd like to call out that the blue lines represent bidirectional dependencies. Class A depends on Class B, and Class B depends on Class A. That should be a red flag, right? You don't want bidirectional dependencies. So if you want to do this on your own code, there's a number of tools out there. This is one that looks pretty nice called objc-dependency-visualizer, and you just run it on your code and you get a chart like this. So here's a real-life example I found. Simple enough where we can actually understand what's going on. So we've got our app delegate, right? This is our entry point. And that creates a font list view controller, so that's probably the root view controller. And you can imagine that the app delegate is creating that view controller and displaying it on the window. Then the font list controller probably has a search button, so there's a search list controller that gets created from that. Now, for whatever reason, these guys also depend on the thing that created it. We don't know why it would need to do that. Probably lack of delegation. If you're using delegates and protocols, that would be a lot better, right? You would depend on some abstract concept, not the concrete class. So this particular developer ran this, understood the problems because it was laid out like this, and refactored his application to this. Notice no more blue arrows, right? So he probably did this by implementing loose coupling on his objects, right? Instead of directly instantiating classes and talking to them directly, especially ones that already depend on you, you can program to interfaces, which in Objective-C terms, that means program to protocols or more abstract concepts. Notifications are another way to decouple objects from talking to each other directly. You can also use dependency inversion. So basically, I accept, either in my constructor or as a property, I accept some collaborator that's going to perform a task for me. That collaborator probably has an interface or protocol. But I don't care what the instance is. I just care that somebody passed me a dependency that I can use to call things. That has a side benefit of enabling really, really rich testing support. So you can set up your objects in different environments and test them however you need to without actually having to set up the whole world. Also reducing God objects. We probably all have seen like the manager classes and the util classes and things like that that the whole application depends on. App delegate is one of those. A lot of people end up putting code inside the app delegate, and then the app delegate grows and grows and grows, and it becomes this huge thing. Another thing is to reduce singletons, right? You can, instead of directly calling out an object that lives in the sky somewhere and has a single instance, you might choose to pass it in through dependency inversion. So why is this important? Well, with less dependencies, you can refactor. That sort of selecting and extracting method becomes a lot easier when you don't depend on 15 things. Or when the things you depend on are rational dependencies, they make sense for your application, and you're programming against interfaces, not concrete implementations. It also allows you to change your mind, right? If I can refactor quickly, or if I can swap one component in for another, it allows me to change my mind. It's one reason why you might want to decouple persistence, say, from networking, right? I was talking to Saul earlier today about pros and cons of taking some web service response and persisting it to disk just as JSON, like text, and then when I need it again, I can just read it, or core data, right? But if I have those two things as different objects and implement the same interface, persist to this thing, then I can pick and choose those things. They're decoupled from the networking code. You can change your implementation. You can add features to your application without being bogged down by the weight of the things that already exist. So as part of this, I asked some people that I respect just some tips that they had as well. So I'll sprinkle these on in the presentation where they're appropriate. So this quote is, ruthlessly modularize functionality, design, implement, and package everything as if it were to be distributed as third-party code. What would your code look like if you intended to release it on GitHub? So you guys know this guy? This is Matt Thompson. He would be what I would consider an effective developer. He produces lots of stuff in the community. He's a primary contributor to AF Networking and a number of other things, NS Hipster. And this was the most ridiculous picture I could find of Matt. So here's a screenshot of the app I work on. And I'm quite proud of the tiny methods, right? So I try to practice what I preach, but there's this line count number that really scares me, right? 1,500 lines of code in one class, that's a lot, right? This is certainly a candidate for refactoring. So extract method until you have good methods, right? Good, short, focused methods. But at this point, I need to be looking at how can I extract other classes, right? Take this logic, put it in smaller classes. There's no like tax on the number of classes you have in your application. You shouldn't be worried about pulling things out of the view controller and putting it into another class. So I would say try to impose limits on yourself, right? That grew without me really thinking about it. It was like the boiled frog problem, right? You start out and the class has 100 lines of code in it, and before you know it, it's got 2,000. You didn't realize you were crossing that limit. So pick a limit, whatever you think it is, and challenge yourself to stick to it. So I asked another person I respect, Cesare, and he gave me these numbers, which I find to be quite aggressive. The max lines of code for a .m file, 150. I'm 10 times that in that class. So, and the max lines of code for a method, I think that's pretty reasonable, 4 to 5 lines. There's no reason why we can't create more methods. And these, you may totally disagree with these numbers and think he's crazy, and you know, you'd be right. But the point is, he picks some numbers and he tries to stick with them. You can also automate this process to avoid yourself from getting in the situation where you didn't realize that you just added 100 lines of code to a class and pushed it over your limit. So if you'll permit me, I'm going to try to write a little bit of awk. Anybody in here an awk expert? Okay, I don't think they actually exist. Okay, so this little script here, we're going to find files in our project that are named .h or .m, but we're going to exclude the CocoaPods because we don't really want to impose those rules on third-party code. And then we're going to print out the file name, and we're going to count the number of lines in them. And then here we're going to check the line count and compare it to this number. 400 was the imposed limit on this project. And if it's greater than 400, then it prints out a warning. So you'll see this in Xcode. Warning, this class has too many lines of code. You can find this script at Matthew Morey's blog, Improved Xcode Build Phases. And I also have these slides online, so at the end I can point you to that URL. So this is a way of just giving that rule teeth, right? Just saying, I want my classes to be 400 lines of code or less. You can't lie, right? You can't get around this rule without deliberately changing that number. And that's something you could agree on as a team to do that. But the point is to automate the rule so you don't have to go tap your coworker on the shoulder and say, hey, you committed this method or this class that has 600 lines of code and we try to stick to 400, right? That becomes a non-issue when you automate things. Okay, so let's talk about some Xcode tips. Completing methods. These methods are really wordy like we talked about earlier, and it took me probably, I don't know, 2 or 3 years before I figured out that you could do this. So I have a table view implementation, and I want number of rows and section there. So before I'd hit the dash, open parentheses, type NS integer, and so I'd have to think ahead of time, what does this return, right? But if you just type -ta, omitting the return time altogether, it will give you all methods that you could potentially implement on this class that start with TA, like table view. So that's a much faster way of implementing these methods. Another trick is to label your views in Interface Builder. So right here I've got a mail message cell which has a content view and a scroll view, and then inside here I have 3 labels. You can just double click on them like you can in Finder and rename them, and that name, it just becomes a little bit more descriptive for you. And this is really handy when you have really complex UIs. Another tip is to learn keyboard shortcuts. This one I can't stress enough. This one keeps my hands on the keyboard and not fuddling with the mouse. I try to keep my hands on the keyboard as much as possible. So if you hit Command 0, it'll just toggle that pane on the left. If you add Alt to that, it will toggle the pane on the right. If you hit Command-Shift-J, it will reveal this file in the left-hand sidebar, the Groups and Files Navigator. And it works even if the items are collapsed. So you can see that on the left there, it's collapsed. I hit Command-Shift-J, jumps me right to that method, which means I can organize my project how I want to organize and not worry about deep folder hierarchies or anything like that. I can always jump straight to that. Command-Shift-Y will open up the bottom panel and close it again. So if you're debugging and you want to get that out of the way, Command-Shift-Y. Command-Shift-C, this brings your cursor straight to the console when you're debugging. So right here, I launch the application and hit a breakpoint, and without using my mouse, hit Command-Shift-C, and my cursor went right in the console there, so I could start typing, PO self class. Here's another more complicated one. I hit Command-Control-J to reveal the header for that symbol that I had under the cursor. And then to get back, Command-Control-Left arrow. So Command Control J will jump you to the header. Command Control back will take you back. It's hard to do these, to say these. It's easier if you picture the keyboard. Here is one that I use a little bit more often. It's the same thing, except I add Alt to that command, which opens it up in the Assistant editor. And then when I want to jump back, you hit Command J to move your focus over to the other window, and then Command Enter will close the Assistant editor. So again, if I'm on a big monitor, I don't want to completely switch out the code I'm looking at to see the header. I just want to reveal it in the other navigator. So again, adding Alt to that opens up in the side. Command J moves focus. Here's one called Edit All in Scope. So say I want to take that message variable and I want to rename it to mail message. No reason why I need to type that 5 times. So Command Control E. And if you use Evernote, Evernote probably stole this keyboard shortcut from you, so you should go tell Evernote, well, you should be nice and uncheck the box in Evernote. Or change it to something else, because I use this a lot more than I search in Evernote. Here's another one I use every single day. Control I. Sometimes people have funky indentation, or they're using tabs, not spaces, or whatever. Just highlight, Control I, re-indents the file exactly how it should be indented. So there are so many to learn. I just barely scratched the surface, and I could bore you for an hour with keyboard shortcuts. And none of you have your laptops in front of you, so you probably would just forget that tomorrow. So the whole point is to just pick a couple, right? Pick 2 you don't know and practice them, like deliberately. So next time you go click on the button to expand and collapse the side panel there, remember, oh yeah, there's a keyboard shortcut for this. Let me go look it up, and let me do that instead, right? Or this is a time when I could have used Edit All in Scope and I forgot. So let me undo what I did and redo it with Edit All in Scope. That's the only reason you're going to learn. And you need to repeat this process until it's ingrained in your memory, right? So now that you've mastered those 2, Edit All in Scope in the left-hand bar, then now pick 2 more and do that. Cheat sheets don't work. You will put them up on next to your monitor, and you will use that as a crutch. Who here plays Rock Band or has played Rock Band? Okay, so I'm a guitar player, so playing a plastic guitar with 4 buttons on it doesn't interest me, but drums do. Like, as a guitar player, I've never been a drummer, so this allowed me to sort of learn from like absolutely no rhythm to proceeding up to very hard mode in drums. And the other aspect of this is this does prepare you to actually play drums, I think. The mechanics, the timing, and stuff like that. You're basically playing a mini drum set, whereas the plastic buttons on a guitar don't really prepare you for playing guitar. However, they give you these nice little guide points of what you need to hit and when, and it's every song all the time. So my brain's on autopilot. I'm like, do. If you take that away from me or turn off the TV and play the same song, I'm like a retard with sticks. I can't do it. It's like I have not learned to do it without this, right? So my brain just completely relies on this crutch. Cheat sheets are the same way. So you have to actually practice it. Snippets are an underused feature in Xcode, I think. And you can pick to use them in Xcode if you want. I have a mixture of them. I use some in Xcode, some in Text Expander. Not for any real reason other than it's a little bit easier for me to synchronize the snippets in Text Expander. So if I type these 3 letters that I will not say out loud, it will expand to property non-atomic strong. You got it. Prop int will give me an assign for an integer. Prop stir gives me a copy for a string, right? I don't want to type all that, and I do this in every class that I create. I'm going to create probably a string property for it. Mark for pragma mark dash, right? So I don't have to type all that out. I like to use the pragma marks with the dash and organize the methods in a class so that when you open up the class navigator, it shows you all your methods. There's these nice dividing lines of where the various sections are. And you can also use that to tuck away the ugly stuff, or if you prefer that. This actually does work, by the way. TVDS gives me a stub table view data source. SWF, string with format. right? I want to save the keystrokes. Like I could type SWF and it puts my cursor exactly where it needs to be to continue typing. tvdel is table view delegate. Here's another one that I use a lot, network activity, network act. And Xcode completes this for me, so it doesn't really matter how long the snippet text is, but I do this so many times, especially because I do a lot of demos that end up needing to call the network. I don't want to type this out, especially when people are watching me type. It's so much easier to just type network act and hit enter, and then I can change the yes to a no and when I need to stop it. So you find yourself writing repetitive code, boilerplate code, make a snippet, and move on. Okay, who here uses source control? Okay, let me flip that around. Who here doesn't use source control? Okay. Yeah, we could have an intervention if we found anybody, but luckily you all use source control. And I assume you're all using Git. So these are going to be Git tips, but the concepts are similar for other language or other platforms. So the first thing, use the command line. I see a lot of Git GUIs that can help people who aren't familiar with the command line get started. But what I find is that they're often way more complicated than the command line interface to Git is. And it is complicated, but you don't need to know that many commands. The idea is you can get by with git status, git add, git push, git commit. Right? You can get by with just a few commands. But you open up a GUI and it gives you 50 buttons, and you're like, well, I'm not sure which one I need to click on. So while there are some GUI tools that do help and provide good functionality, you will understand Git better if you start out using the command line. So I use a GUI, I use gitx for specific tasks like staging hunks of a file as logical commits. So this is gitx. There are a bunch of forks of gitx. The original gitx is no longer maintained, so I use this one by Rowan J. If you look at the gitx forks list, there's probably 30 of them, and they all have different features. I don't want all the features. I really just want a list of branches, visualize timeline, and a staging area, which I didn't take a screenshot of, but the staging area is what I use the most of, and it allows me to just say, okay, this section of the file, I'm going to stage that. This section of this other file, I can stage that. And the reason why I want to do that is because I want to make my commit a logical chunk, right? A commit is not Command S for your source code. It's logical changes over time. So if I fix 2 bugs in the same file, that's 2 commits, not 1. So commit in logical chunks. Write a good commit message, right? You should be able to go over later on and say, why is this change there? Git blame on that line of code will tell you who made it, when it was made, and the commit message. And if that commit message says, fixed some stuff, then that's not helpful. This is a guideline on what a good Git commit message is. At the top, you have a capitalized short summary, 50 characters or less. In gitx, they give you a line, which is a guide marker on when to stop typing the summary. The idea is that you have a one-liner. If you type git log -- one line, it will give you the shortened version of git log, where you have the short SHA and just the summary part of the commit message. So that would just show you this, right? And it's going to chop it off at 50 characters, right? The idea is you have a summary of your changes, and then, you know, this is the TLDR, right? And the stuff below is more, you know, discussion about, well, I tried this and it didn't work, or this code came from Stack Overflow, here's the link, or whatever. Those things don't need to go in your source code comments. We have source control for these reasons. So this is what git log -- one line looks like. And, you know, clearly I have broken this rule, but it should be sliced somewhere up like that. But it's fine, you know, we don't have to live by this rule all the time. But other tools like to assume that you do, like GitHub. So this is a commit, I think on CocoaPods, and GitHub is trying to like make the summary bolder and bigger font than everything else. But in this case, he just kept typing, right? And it's not a terrible commit message. I'm just saying that GitHub does this, and your commits end up looking a lot nicer, especially if you have some discussion points below. They are in a smaller font. In Git, branches are basically free. So I use branch for everything I do, right? I start off writing changes on a branch. If you're not familiar with Git's internals, a branch is basically a pointer, right? I've got 2 branches here, and they both point to the same commit. There's no additional weight or disk space used or anything. And these green little boxes are called blobs. And when I commit on C3, on the issue 53 branch, all I've done is add another commit, right? Again, the branch, like we're still in a linear timeline, right? You think of branches as diverges, right? But we haven't diverged yet. The only time that happens is if I go back in and I make a different commit where the parent is C2, right? So now we've got C3 and C4. Their parent commit is C2. So at this point, now I need to merge. And merging master, or merging hotfix onto master, is just a fast forward, right? There was no additional steps to move master from here to here. So you call it a fast forward. So I'll talk for a minute about rebasing. Who here uses rebase already? Okay, who here is scared of rebase? I was totally scared of rebase when I saw it. People kept trying to explain it to me, made no sense. It sounds terrifying. And also, since you're messing with your source code history, you have a rational fear of messing things up. So I'll do my best to explain why I use rebase and what it is. So say we have some commits here going up in time. So the most recent commit is the empty circle. And the empty circle is not synchronized to origin master yet. We haven't pushed it. So it's just sitting on my box. So let's say I pull down all the changes. I do a git fetch to pull the changes from origin. And there's this new commit that I didn't have before. And its parent is the same as my parent, my commit's parent. So we have a divergence here, right? So what would happen is if I just said, okay, git merge, origin master, then we get this little merge commit right here. And we call this a merge bubble. And you've probably seen this in your timeline. You get all these merge bubbles. This is what happens when you do git pull by default. If you do git pull, it does a git fetch, then a git merge as one command. Instead, if we were to rebase, we're basically just reparenting that commit on top of what origin has, which is what I wanted in the first place, right? Take all of the changes from the server, then put my changes on top. That's all that means. And at that point, your timeline is now linear, right? There are reasons to merge still, but when you're doing git pull, I always use git pull -- rebase. Always, always, always. So I made that the default. I don't want to type things that I don't have to. So git config branch.auto setup rebase, always. We'll always use git pull -- rebase. The only caveat to this is to never rebase public branches. So that master commit, the empty circle, was only on my machine. I'd never pushed it anywhere. Once it's on a public branch and somebody else has cloned it, and you rewrite history, you change the parent of that thing, they're going to have a merge conflict. And that makes you a horrible person to impose ugly merge conflicts on other people. So never rebase public branches because when you do, you're going to have to git push -f to force your changes on the server. And that's a dangerous thing. We call it git punching. You just punch your changes into production. The only time I ever do this is if I have rebased to squash commits together and clean up the history a little bit on my own branch that I know nobody else is using. And in that case, I may do git push -f, but it is a dangerous thing. It will lose data on the server. Next tip I want to talk about is git bisect. Who here has not used git bisect? Okay, git bisect is my favorite Git feature. It's so awesome. It's also got a terrifying name. It sounds like you're about to do surgery. Okay, so bisecting is literally just taking a list of things, dividing it in half, right? We're going to bisect this work. So I'm sitting on this commit right here on my machine, and I realize there's a bug in something that I'm working on. And I didn't write it. I don't know when it came into the system. What I do know is that it didn't exist 2 weeks ago. So I've got my timeline of commits, right? I type git bisect start, which puts me in bisect mode. And then I mark this commit as bad. I'm sitting there. It's basically my head is, this is the head pointer in Git, so it's going to mark that commit as bad. Next, I check out head ~15, which brings me to here. And then I say git checkout good, or git bisect good. And I have an empty keynote slide in there for some reason. Okay, so the next step is Git will automatically jump to the midpoint between those two commits, right? And it's going to ask me, is this good or bad? So I'm going to open up the simulator. I'm going to tap looking for the bug. If we have automated tests, then this becomes a lot easier. But at some point, I need to say git bisect good or git bisect bad here. And so I say it's bad here. So I type this at the bottom. Now it knows that all the commits from this point onward are bad. So let me divide the list in half again, pick the midpoint. Now that one was good. The bug did not exist in that commit. So I say git bisect good. See how we're zeroing in on these without testing every single commit in the list? And then again, we check out the midpoint. I say that one's good, so it colors those lines green. And then finally, it goes to the last one and says, is it good or bad here? And I say it's good. That's the source of the bug. And if I do a git blame or git show on that particular commit, if I do a git show with that SHA, it should tell me the developer who wrote it and a descriptive message of what he changed. And if it says fixed bugs, I'm going to scream because that's just lazy, right? The whole point of having source control history is so you can rewind and know exactly what you're thinking at the time when you wrote this code. You could say, oh, I copied and pasted this from Stack Overflow. And then that's valuable information. You know that was a bad idea. So I mentioned having automated tests. If you have a shell script you can run that gives you a 0 or 1 exit code based on the result of your tests, and you can expose this with a test, then literally that whole process of bad, good can be done in one command by saying git bisect run with your script. And for every step of the way, it will just run your script instead of asking you. So we'll often reach a point where we make a mistake in Git. Oops, I merged. I did that git pull thing, and Ben told me that rebasing was better. What can I do? Well, in that case, you can actually just reset to one commit behind and do your work again, right? There's no problem with that. But if you do something like, let's say I rebased and I made a big mistake, and I lost commits, right? Still, fear not, all is not lost. We have the ref log, and the ref log is literally just a log of all the commands you've run. And so you can say, oh, you know what, this commit, it has data in it that I accidentally deleted through a rebase. I can just pull it out again. And it's got a SHA on it, so you can just merge that in with your source. So just don't always be afraid of the commands for fear of you're going to delete data, because usually you can get things back with a ref log, and then you feel like this, where you're empowered to do good things with Git and use the features the way they were meant to be used. So I mentioned I use branch per feature. I always keep master releasable. Master, in my opinion, is releasable code. I should be able to deploy this to the server or ship this to test flight so my testers can use it. I want to keep master releasable at all times. So I don't want to veer too far from working software, right? And when I do, I want to do that on a branch. Like all the complicated rebasing and merging and conflict resolution, all that stuff, it always happens on a branch. And only when I'm ready do I merge that back into master. Here's another quote. I attempt to keep the app in a working state as much as possible. That means test driving small changes, committing often, and only hooking up things to the UI when I think they're ready. If I'm not in a position to push my code at least every hour or so, I feel like I haven't broken my work down properly. I really resonate. This quote resonates with me. I like to keep my code in a workable state. Stu Gleto said this. On my bash prompt, I have a little snippet of code that checks the last time I've committed in that directory, and it puts a number of minutes since last commit. And I've even seen people do this where they color it increasingly red over time, and if it gets to an hour, then the font color is red. Mine stops counting at 2 hours, but it's a little indicator that I haven't committed my work in a long time. And I want to be able to commit often, right? Make smaller logical changes, not gigantic leaps of faith in functionality. At the end of the day, I don't want my code to look like this. I'm going to walk in Monday morning and just, you just throw everything you did away, right? It's not in a good state. The code is in disorder. And oftentimes when people come and ask me for help, I'll sit down next to them, and their code is like this. There's lots of half attempts. Well, I tried this, and then I commented it out, and I tried this other thing, and that's commented out. Like, we have branches. You can take all your ugly work, throw it on a branch. If it doesn't work, you just delete it. Like, you as a person are more knowledgeable for having gone through that process. We don't need to keep the source code around, especially if it looks like this. Kent Beck, famous Kent Beck, said that if at the end of the day he has not reached a point where he's sufficient with his design, he will just throw it away and start clean the next day. Which I think is pretty hardcore, but the whole point is the code is not the important part. It's your thought process, the things you learned while writing it. And if it is in a state of disorder, when you come back to it the next time, refreshed and energized, you're probably going to do a better job. And to avoid yourself getting in a situation where, I don't know how many meals they cooked in here before cleaning the kitchen, but really you want it to look like this. And the way I keep my code looking like this is by trying to tackle smaller changes. I break down a problem into a small manageable chunk. I've got 2 hours before the end of the day. I'd like to go home and eat dinner on time with my family. I'm not going to attempt this gigantic refactor. I'm going to break down something that I can do in that time frame. So I'd like to end this section with some effective habits. So Kent Beck, another quote, "I'm not a great programmer, I'm just a good programmer with great habits." I feel like this describes me. I think I have good habits. So I like to keep an improvement list, things that I notice that I'm doing that I could be doing better. I should have written a test for that, or I don't know, maybe I don't know how to test that thing, so I'm going to, I can't tackle that right now, I'm going to put it on my list. Or I need to learn how to do this with a keyboard shortcut, or whatever. And then every day, you can look at your improvement list and just pick something and try and tackle it, I also am a big believer in having a side project. There are oftentimes things that I am not comfortable introducing into client work because I'm not skilled enough, I'm not knowledgeable enough about that thing. Like, let's say it's my first project with core data. Don't put that in on your client project your first time. Pick a small example, something that you're doing on the side, and do things there. And I like doing this because it keeps me working on stuff that interests me, like problems that interest me, and work benefits from that greatly, right? It allows me to try things. Like, let's say at work on a Rails project, we use Rescue, but I've been really hearing about good things about Sidekick. So on my side project, I use Sidekick instead of Rescue. And now I'm equipped to say, yep, it's better. I'm going to use it on my next client project. And I'm equipped with that knowledge. Also, read other people's code. There's so much stuff out there. And you're going to learn something about all the code that you write or read. Here's another quote. "I form opinions about the code I study. Not all of it is good. I want to reflect on why I feel that way." Jonathan Penn said that. Again, the most ridiculous picture I could find of him. Here's something that's near and dear to my heart. I wish they had college courses or maybe even high school courses with this topic, to learn to ask for help. Earlier this morning in the keynote, we saw that ridiculous Stack Overflow question. I have a similar one here. My client server code is not working correctly. So, like, right off the bat, the title is worthless. It doesn't tell me who cares if it's client server, and it doesn't include error messages or anything. And it, in the body of the question, I get some code of a client server program, and I also want to be clear that I'm not picking on this guy because English is not his first language. That's not at all what I mean. What I do mean is deliberate things like "I have" is misspelled. It's just he's rushing through it, right? Below, check what is the problem. Like, these things like matter. I think they matter. You're asking somebody to give up their time to help you. And basically he's saying, here's my entire program. It doesn't work. Please tell me why. And he's not equipping, he's not setting himself up for success, right? And guess what? There were no answers to this question, right? Of course, who's going to help this guy? Think about what you're asking somebody. Distill the problem. You don't ask 5 questions. You ask 1 question. Distill the problem, reduce variables. And more often than not, you will find what the problem was in the first place, right? Like Joel was saying this morning, if he had asked a more general question of what are your tactics for finding the missing brace, he may have very well found the brace in the process of trying to reformulate his question. This also works for email and bug reports, right? How many of us have gotten a bug report that said, it doesn't work? Thanks. Now I have to take my time, reproduce the problem, try and figure out what the actual underlying issue is, and then suggest a fix. And email, right? Email, it gets me every time. Somebody will send just verbal diarrhea in an email, and they've CC'd 12 people. I don't know what I'm supposed to do with this email. Am I supposed to just read it? I'm probably just going to throw it into the trash because they didn't ask me to do anything. If this email instead said, this is a thing that we're doing, Ben, I need you to call customer X. Well, now I have an action that I can do. There needs to be an action for the email. Oftentimes when I'm writing an email, I'll realize that there's just too much detail and nobody's going to read it, right? And I value the people's time who's going to read my email. I'll write my own TLDR at the top. And then you may even take that one step further and say the TLDR was good enough and just delete the detail that you wrote. But again, I think this needs to be college, material for college courses. Have people be effective in a workplace. Here's another quote. Before asking for advice, take careful look of what you know and what you're looking to have answered. Often that will put you in a spot where you answer your own question. Daniel Steinberg said that. This is him holding an elephant foot. At Chai 1, we have a rubber ducky that looks sort of like this. And the idea is that oftentimes we will ask a question, say, oh, I can't figure this out. Can you come here for a second? And they're like, I don't know if I'm going to be able to help you. This isn't my project or whatever. I don't know any of the code. And they're like, no, just listen. And that person proceeds to explain the problem. And they're like, well, I have to tell them about this. And and I already checked that. But I didn't check this thing. And then in the process of explaining the problem to them, they're like, oh, thank you so much. I figured it out. It happens so often. So the idea is that that person is a rubber ducky. They may as well be a rubber ducky, right? They're just sitting there to listen. Sometimes you can just pull in your significant other and explain the problem to them. And my wife is non-technical, and she'll just roll her eyes at me when I'm telling her about this stuff. But in the process of telling her, I discovered the answer myself. So I also think it's important to program in other languages. My current languages of choice are Objective-C and Ruby. But every once in a while, I will write something in JavaScript and probably hate it, but it expands our horizons, right? I wrote a game in Python once. That was pretty fun. I was tinkering with Go recently and wrote a little mini web server in Go, and it was fun. Stu Gletto also said, don't just program in Objective-C. Make sure you regularly use another language. There's a lot we can learn from other technologies and communities. I have a past history in .NET and now mostly Rails and iOS, and I've brought something with me from every single project I've been on, every thing I've done. I've learned from those communities, and you can see the cross-pollination happening. RSpec is a popular behavior-driven development style of testing in Rails or in Ruby, and that same style ended up getting ported to Objective-C through Cedar and then Kiwi and Specta. Those frameworks were inspired directly off of RSpec. And I'll leave you with one last recommendation, and that's to write tests. As a community, the iOS developers don't really write tests at all on most projects I see. The tooling is getting better. Xcode gives you a test project on every project that you create. And I think we need to use that more and more, right? In XCTest, you can actually click on the sidebar and run the test right there. I think it's really important for us to create working software and have the confidence to refactor. So with that, it was a whirlwind tour of a lot of things, and I would just ask you to go forth and be effective in what you do. Thanks. Looks like we have 5 minutes for questions if anybody has a question.
This is probably terribly off topic, but do you have any advice for folks that are trying to do continuous integration with iOS projects?
Yep. I have a screencast on it. However, I'll just give you the salient points. You can use XCTool or XCPretty to make command line builds a little bit easier. XCTool is from Facebook, and I think most people are using XCPretty nowadays, which basically uses Xcode build under the hood and analyzes the output, so you can easily grab test results and things like that from the command line. The whole point is to make your build work on the command line first. That's step one. And then step two, I use Jenkins. And we have Jenkins doing stuff like we've got a push button deploy to test flight. We've got automatic update of provisioning profiles and certificates. So it actually looks in the folder. We just check those into source control. Apple Doc, generating Apple Docs if the project wants them. Trying to think of other things that we do. You can do things like take screenshots in various locales using instruments. But whatever you can do, as long as you can script it, you can have Jenkins run it. And we've had pretty good success with that.
What do you use for UI
UI testing?
testing?
So I've used Kiwi in the past. KIF. KIF is a project from Square. We ran into an issue with KIF. Somebody had produced a fix for that issue, but they refused to sign their contributor license agreement that they require. So at that point, and we needed the fix, so we jumped on their fork of the project, and that kind of uneasy depending on those things long term. And at that point, I don't really know what happens to the code. You know, if that project requires a contributor license agreement and the person who wrote the code is unwilling to put it in there, then I don't know if they can ever put it in, right? Like the same code. I'm probably going to lean more on UI automation in future projects, and there are some frameworks out there that make that a little bit easier. Jonathan Penn's book on UI automation covers making it more like an assertion style system that can be used in CI environments. But we use Kiwi and Specta for our testing, and there's enough XC test support where you can click on the top level and have it run tests, and all of the test failures show up in Xcode as well.
Preference on the IDE?
Preference on the IDE? I like AppCode, but I don't want to run both at the same time. AppCode is kind of ugly and slow because of its Java heritage. It doesn't really look like at home on the Mac. However, being an old .NET developer, I was a big ReSharper user. And so many like the refactorings and the finding dead code and like making it gray so you can know that you can just delete it. Finding usages of things so that you can go refactor a little bit easier. All those things are far superior to Xcode. So my long wish is for that just to be a plugin into Xcode, but all right, thanks.